So let's talk about frames. Okay. So we have jacked the robot, and we have seen that it moves in two ways. Okay. So you can move in the joint frame or partition frame. Okay. When we talk about joints, we are moving in individual joints, and when we're talking about partition frame, we're moving in the XY coordinate. So if you remembered yesterday, so if I have a 1 degree of freedom robot, theta, the position of the end of arm tooling or the end effector can be described as X, Y in the partition frame. But in joint frame, it could be described by R theta. Okay, so you could move based on theta or based on the angle, or you could move based on XY. Makes sense? Okay. Now for the robot here, there are different types of partition frame. One is the word frame. Okay. And the word frame is located in the world. So again, we draw the skeleton of the robot. So we say that this is joint 1. This is joint 2. So joint 1 is the waist. This is joint 2. Okay? So the position of the world frame, the origin of the world frame where everything is based, is the intersection of the axis of joint 1. So where's the axis of joint 1?
Straight up.
Straight up. That's the axis of joint 1. And joint 2 axis is here. So this is where your world is based. Okay? And then you have joint 2 or joint 3, and then your joint 4, joint 5. Joint 4 moves this way, then joint 5, and then joint 6. Alright? Any question? World frame. So when you press that position, okay, so for the world frame, this is X, this is Y, and this is Z. So it's the right hand rule, the purling. So towards me is X, and across is Y and Z. Right? So when you press position, you could see J1 to J6 if you want to see the joint position. Okay? And if you press world, you will see X, Y, Z, and then you have yaw, pitch, and roll. It's not rock and roll, pitch and roll. Okay? So what is yaw, pitch, and roll? We go back here and we just write our right hand frame here. So if this is X, this is Y, and that is Z, yaw is the rotation with respect to X. Okay? That is yaw. We don't use Y because Y is already used by this. Pitch is rotation with respect to Y. Okay? That's Y. And roll is rotation with respect to Z. It wasn't done any habijak. So can you illustrate this motion of yaw, pitch, and roll?
With the robot?
With the robot. So what coordinate are you in now? So how do you go in world? You still have a fold? No? Okay. So when you move, you're gonna move it because the blue one, the blue buttons needs to be paired with shift. So anything that moves, you have to have shift. Okay, just move X and Y first so that we'll see. Positive X. Can you kind of increase the speed? Positive X. So that's positive X. Positive Y. That's negative Y. And positive Z. So where is X again? Okay. And now try to do yaw. Can you see where yaw is? It's W there, right? Okay. All right. So you see how it rotated with respect to. You have your x-axis here. It's rotating with respect to the x. Does that make sense? How about the y? If you want to rotate that way, you have to be in y. Rotate it with respect to y. You see, it's rotating now with respect to the y-axis. Okay. Can you go down to that? Go back to that so that you can see down to that y thing. Okay, now rotate, roll. No, roll is X, Y, Z. This is still X, Y, Z. When you do the roll, it should rotate with respect to that Y. Okay? Okay, now, can you rotate it this way? In the Z. That way, yeah, that way. Okay? Now let it go up. And let it go this way here. Did you rotate? Or no, you just move X or Y. Just move Y. You see? It's trying to compensate because it maintains that orientation. Okay? So the first three here is position. X, Y, Z. Okay? The third here is orientation. So when you move, so this is positioning, you move to a certain position and then you orient your end effector. Okay? So any question on world frame? Okay? So world frame is based, the origin of world frame is here.
Why do they do that instead of putting it at the waist?
What do you mean? Instead of putting it in the
I mean,
waist?
they put it at joint 2, I guess. I just wonder why it wasn't at joint 1 or at the end of the arm. Like what made them pick joint 2?
Oh, this one here?
Yeah, to make it the origin.
Because this is where when you draw,
I guess they can't do it.
you really can. It's difficult for me to make it here. It's easier if I have it.
Right, okay, so I guess at that point,
Okay?
yeah.
Why is it more difficult to have it at the
Waist.
bottom?
Because from the waist, if I put it down, I need to do this.
You'd have to have an offset in order to go
Oh.
Z. It would always be shifted by a certain amount. So
Right. Does that make sense?
Oh, yeah.
Okay? Now, if you remember in your dynamics or statics, we have vector positioning.
Yeah.
Okay? So if I go back to my research in apple picking, and I have my camera here. So based on the world frame, that is the position of the apple. Okay? But I could not, here I could not see what's the position of the apple because the robot doesn't know. But the robot knows because the links are interconnected. The links are interconnected. The robot knows the position of the hand. Even whatever thing I move it because it's based on that one and that one. That makes sense? So I put a new user frame here in my camera. So I call that my camera frame. And I could now connect to the apple. So when I do my program, I will have R of the apple is equal to R hand, which I know wherever I move, plus C frame. So this is where, after word frame, this is where user frame come in. Okay? Because the word is inherent in the robot. Everything is based on this one. That is why the word frame is designated as user frame equals 0. You can designate up to 10 user frames, different frames. Now when you designate a different user frame, like for example, I designate the corner of this one as my user frame, okay? So I designate this as a user frame. I have X, Y, Z. Is that correct? No. This is X. Now, the user frame, you always just have to remember right hand rule. You don't have to follow. I could make my X this way. Okay? I could make this my Y, but then we have to follow the right hand rule. So where will be the Z? So I don't have to follow what the user frame's XYZ is. Okay, that's why when we teach the robot another user frame, all we need to do is teach the robot where is the origin and where are the two axes. Where's the origin and where are the two axes? And then it will, and then you will see, wow, the robot does it. It's because, again, it's the same thing as this camera that I told a while ago. This one here, because that is inherent to the robot, that is always constant. Robot already knows that one. But this one, I taught that to the robot. Boom. The robot now knows where's the origin, where's X, where's Y. So when I do programming, this is now the vector that teaches where the robot goes. Does that make sense? So that's the convenience of the user frame. So if I have this jig that I do my robotic thing, I could just point this one and do. So I already have that program, right? But then when the factory grows and I have to move this jig, or I have to add 3 more jigs, I don't have to create another program. I just go teach the robot this is the origin. The robot does the same thing. Okay? So that's user frame.